Hi, we talk about back-to-back stem and leaf plots in this lesson. Um, the reason we use back-to-back stem and leaf plots is because we want to compare two sets of data. So you can see the two sets of data side by side in a stem and in the back-to-back stem and leaf plots. Let's look at an example. This is the test results for class A. They've got the smallest mark is 10, 14, 18, 35, and so on. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 students in class A. And this is the test results for class B. We want to show these results on a back-to-back stem and leaf plot. Let's start with class B. With class B, we do exactly the same way that we do when creating a single stem and leaf plot. So for class B, there is no mark in 10. So you write 1 at your stem, this is your stem, and nothing in the leaves. The smallest mark you have in class B is 25. So you write 2 at your stem and 5 at your leaves, and that's the only mark in 20s. In 30s, you don't have anything. Again, you got 3 here and nothing in the leaves part. In 40s, we have only 1 mark, so 4, 45. So we write 4 here and 5 at the leaf. So that shows 45. That represents 45. Nothing in 50, again, so write 5 in your leaves. In your stem, and nothing in your leaves. In 60s, we have 1, 2, 3, 4. 4 marks in 60s. So write 6 at your stem, and then 2, which represents 62, which is that mark. Then 67, which is that mark, 68, and 69. In 70s, you have 1, 2, 3, 4, 5, 6 marks. So 70 itself, so 70, that represents 70 and 75 and all the rest. And the key here is 1, 2. So 1, the vertical line, 2, that means 12. So for anybody who reads that, they know that when they say 1, 2, it means 12. It doesn't mean, for example, 1.2. We do the same for class A. The two sets of data share the same stem. So the smallest mark for class A is 10. So that's 1 at the stem and 0 at leaf. Then you got 14, again 1 at the stem and 4 here. That represents this 1 and 4. Together represents 14 and 18. Nothing in 20, so that's why in class A, to the left, I don't have anything at my leaves. Then in my 30s, I have 35, so that's 3, then 5, 35, 37, then 38, so 3 and 8, and 39, 3 and 9. And we keep doing that until we've completed all of the scores. So this side represents class A, and this side, the right side, represents class B. As you can see, now you can easily see the spread out of data. For example, class B is very quiet towards smaller marks like 10s, 20s, 30s, 40s, and even 50s. But it becomes crowded or clustered towards the larger marks like 60s and 70s. But class A has got marks in 10s, in 30s, in 60s and in 70s. Now, by looking at this, we can answer some of the questions. Which class did better in their test? Obviously, class B did better in their test because their marks are clustered at higher marks, like all around 60s and 70s. Only you have one in 20s and one in 40s. But class A has got, as we said, in ones, in 10s, in 30s, and in 50s. And then I've got 3 in 60s and 2 in 70s. So class B did better. Comment on the shape of each data. As you can see, class A is more symmetric. So you've got here, if you look at the shape, it is more symmetric. You've got marks here, one mark here, and almost the same amount of marks on this side. So this shape is a bit more symmetric. But class B is not symmetric. They are clustered only on this side. You don't have any marks on this side. So we say that this is skewed. And because if you draw a line like this, in the way that I'm showing with the arrow, your tail, you have a tail here. And the tail is towards the smaller marks. So we say that that is negatively skewed. So B is skewed, but A is relatively symmetric. Thank you for your attention.